the Swinburn test on the DC shunt motor. Swinburn test is nothing but the simple no load test. It required only one reading, and from this one reading we are going to calculate efficiency and losses of the DC motor. So it is one type of prediction type. So it is a simple DC shunt motor. So positive terminal we have taken from phase positive, positive terminal to ammeter. Ammeter we have taken 10 ampere to the L for the starter. Armature terminal of the starter A is connected with the ammeter, and ammeter second terminal connected to the A2, and A1 and A2 is connected back to the supply negative. Similarly, the field winding F is connected one variable rheostat to vary the speed, to maintain the constant speed during the practical, and we have connected one ammeter in series with the field winding and goes to the F1 and F2 goes to the negative value. So here the complete loop is there. One is the through the ammeter A से field, A से हमारा now A is connected to the armature winding, negative terminal goes to the negative terminal. F is connected through rheostat, ammeter, F1 and F2 goes to the negative terminal. Now what is the procedure? Procedure is that we have to conduct the no load test at rated voltage and rated speed, so that when the rated voltage is there, your iron losses will be rated down, and when the speed is constant, the rated speed, then we can say that windage and frictional loss are constant. So we are able to calculate the constant losses of the DC machine, isn't it? Now what is the rating of the machine? Here it is 1.5 HP, output of the motor is 1.5 HP, then voltage is 220 volt, maximum full load current is 6.3 ampere, 1500 rpm. So we have to keep the 1500 rpm, and based on this nameplate reading we are able to calculate the efficiency at full load 50%, more than full load condition 20% loading, and so on. Now we will start the motor. So by starting this one, so as this is a DC motor, it always gives some sparking over there. Now you will see the speed is, now it is perfect 1500 rpm. So your speed is rated speed is there 1517, 1514. So okay, so this is the speed is almost rated value. Now we will measure the current and voltage. So see here, in this case your ammeter is showing negative. The meaning is that we have to change the direction. Okay, so we will switch off the supply. This is many times it is got happened. So we change the terminal for DC ammeter and DC voltmeter. You have to take care the polarities, otherwise it does not show the correct reading. Okay, so we are going to change the polarities over there. So
sir.
now
बरं, म्हणजे डॉक्युमेंट ओरिजिनल चालेल. मग मी संध्याकाळी करतो तुम्हाला फोन. हां हो.
so now our speed is as it is 1500. Okay, so we have measured the speed. Now the current is around point, this is 5 ampere range is there, so 0.4 is the armature current under no load, and 0.545 is the total current. So the meaning is that 0.05 current is taken by the field winding. So only this rotated voltage is 230, current is 0.45 is the armature current, and main current is the 0.5 ampere. So this 3 reading is sufficient for calculating the efficiency and losses of DC shunt motor. Now this Swinburn test, that is a no-load test, is applicable only for constant machine. We cannot conduct this test for the series motor or where the speed is variable. So therefore this test has this advantage is that it is a no-load test. We cannot measure the temperature rise, we cannot measure the vibration, we cannot account the commutation process or sparking over the brushes, because it is the no-load test. So, but it has a numerous advantages that power requirement is smaller and even big machine can be tested in the lab. Suppose we have a 100 HP motor, 100 HP load is not available, so but no load test can be carried out on 100 HP. So this is most popular method to calculate the efficiency and losses in the DC machine.